Hello everyone. In our last video, we covered the power rule, and we also covered derivatives of exponential functions. In this video, we're going to do two more rules. So they're called the product rule and the quotient rule. So we'll go over each. I'll give you many different examples, and that'll be about it for this video. So let me give you the first rule, which is going to be the product rule. So this is called the product rule. The reason why it's called product rule is it lets you find the derivative of a product of functions, so one multiplied by the other. So here's the rule. So in order to take the derivative of f of x times g of x, so for this we're going to let f of x and g of x be two functions, our functions. Then to take the derivative of one function multiplied by the other, you do the following. You take the derivative of the first function, and that can involve any other rule that you've learned before. Then you leave the second function alone, so g is unchanged. Then you'll put a plus, and then you'll leave the first function alone, and then take the derivative of the second. Now it's good to note here that because addition is commutative, you could rewrite this as this term here, f of x g prime of x, plus f prime of x g of x. So the point I'm trying to make is it doesn't really matter which one you take the derivative of first and then leave alone. Addition goes either way, so you could do it in either order. OK, so let's go ahead and put this rule to test here. We're going to find the derivative of y equals x squared plus 1 times x cubed minus 3. And if you feel pretty comfortable about what this rule says, you might want to pause the video, try this, and then skip to where I have the answer. So I'll let you do that if you want, but I'm going to keep going. So you could think of this first function here. That's kind of like our f of x. And this one right here, you could say that's g of x. So it's this function times this function. That's how it relates to this. What I'll do is I'll go ahead and follow the rule. So the first thing I do to calculate y prime is I take the derivative of this. Now this is the power rule. So derivative of x squared is just 2x. And the derivative of 1 is 0. So I'm done. Next, the rule says you just rewrite the second one. So I'm just going to rewrite this function unchanged. Then I'll do my plus symbol here. And now I switch the order. So I'm going to leave the first one alone now. So leave f of x alone. And then I'm going to take the derivative of the second one. So that's what this says. So this is going to be 3x squared. And then this will just be 0 as well. So this is the derivative. That is the answer. I could simplify, so I might as well. I'm feeling not lazy today. So I'll multiply 2x to each of these, and I'll get 2x to the 4th minus 6x. Here, I'll distribute the 3x squared here, and I'll get 3x to the 4th plus 3x squared. And then I see like terms that I can combine. These two make 5x to the 4th. I have 3 of these x squareds, and I have minus 6x. So this is the fully simplified derivative of this equation right here. Now, I will point out that there are many ways to do these problems, and let me show you an equivalent way you could have done this. So this is an alternate way to do it. So alternatively, you could start with y equals x squared plus 1 times x cubed minus 3. And we could rewrite y first before we even take a derivative. We can make things look different. So how would I do that? I would FOIL. I would get x to the 5th. The last ones here would be 3x squared here. I'd get plus x cubed and then minus 3. So this is still y. I haven't taken the derivative, but now I will. And if you take the derivative here, you actually don't need the product rule anymore because you multiplied it out. This is just power rules. So here I have 5x to the 4th if I take the derivative of this piece. This is minus 6x, and this is 3x squared. And notice, it should, if I did this right, it should match what I had earlier, and it does. So there are different ways to do problems. I actually think that multiplying it out this time might have been easier, just looking at the two. All right, let's try a different example. So let's do the following. We're going to let f of x, that's going to be x to the 4th times 2 to the x. So this is clearly a product rule problem because I wrote a multiplication symbol here. In this case, I don't really see two convenient options for rewriting what y equals here. So I think I would be kind of forced into doing the product rule right away, based on what we know so far at least. So you could label this as f, and then this one could be g. And we'll go ahead and follow the rule. So f prime of x. I'll take the derivative of the first one. It's 4x cubed. Leave g alone. And then a plus symbol, and I'm going to switch the order now. You're going to leave f of x alone. And then do you recall what the derivative of 2 to the x is from the last lecture? Well, that derivative is 2 to the x times ln of 2. I wrote that very weirdly, but that's ln of 2. So looking at this, I think I'm OK with this being my answer. You could maybe factor out a couple things here. So if I wanted to, I could factor out 3 x's, well, x to the 3rd from both of them. I also see a 2 to the x that's in common with both of these. And if I write what's left, I have a 4 plus everything else is factored out. Here I have one of these x's are still here, and I have ln of 2. I mean, I guess that looks a little better, right? I don't know. This would be nicer to have factored because then there's applications to this where you set the first derivative equal to 0. It's much easier to figure out how to set this equal to 0 than something like this. So it might be good to get into the habit of trying to factor things and make it look nice like I've done right here. Don't be lazy. That's what I'm trying to tell you. OK, let's do one more example of the product rule. So this one, it's a little more abstract because I'm not going to give you actual formulas. So we're going to say let h of x equal f of x times g of x. This little dot will just be times. All right, so we know the following. If f of 3 is 2, f prime of 3 is 7, g of 3 is negative 1, and g prime of 3 is 11, we're going to find h prime of 3. So it's a lot of information, kind of information overload, but don't worry about it. So we're not given an actual formula for h, f, or g, but we do know that h is the product of two functions. So if I wanted to figure out what h prime is, like it's asking, I'm going to use the product rule. And this might actually be easier than being given functions because what it's asking you to do is say, OK, what's the product rule? Like, what's the formula? So I'm really just going to write the formula. So to find the derivative of a product, let's write the product rule. It's f prime g of x plus f g prime of x. And that's it. It doesn't matter what these two things are. That's the rule. Now, if I'm looking for h prime of 3, I just need to plug in 3 for every single x you see, all 4 of them. So we need f prime of 3. We need g of 3. We need f of 3. And we need g prime of 3. And conveniently, all 4 of those things are found back up here in the problem. The test here is that you wrote everything in the correct order, because you can't mix these up too much, or you'd get a different number. So f prime of 3, that was given as 7. G of 3 is negative 1. f of 3 is 2. And g prime of 3 is 11. It's hard for me to see right there, but that's 11. So this is negative 7 plus 22, or 15. So even if you're not given an explicit function, you can do this abstractly for other functions. You should practice doing that, because not only are we going to give you actual functions to take the derivatives of, but we'll give you things like this where it's abstract. So practice finding the derivative in general, even if it's just the name of a function. All right, very soon I will show you the quotient rule, so I'll see you in just a second. OK, so we've covered the product rule, and now the quotient rule is the other one we're going to go over in this video. So let me go ahead and give you this rule. So we're going to assume that g of x is not equal to 0. Then the way you're going to take the derivative of a function divided by another one, so f of x divided by g of x, is going to be g of x f prime of x minus f of x g prime of x all over g of x squared. So this is a lot. It's a little bit more complicated than the product rule. And one thing I should point out here, like I did last time, is this cannot go in any other order. You can add two numbers in any order you like, but you cannot subtract two numbers in any order you like. So the way I've written it here, this is how it must be. Okay? So be very careful that you're taking the derivative of the top first, and then you subtract the derivative of the bottom next. So that's the order it has to go in. So this one, there's a lot of caution in the order that you use here. The way I remember this from high school is the song I would sing is low d high minus high d low over low squared. And f of x is high, and g of x is low, just because that's where it is in the fraction. So it's low d high minus high d low over low squared. Even as I was just writing the rule for you, I was going slowly and I was singing that in my head. So that stuck with me all through high school. Maybe it might help you. Maybe not, but it's worth a try telling you. All right, let's give this a shot. So we're going to say y is equal to x squared minus 1 over x squared plus 1. You would recognize this as quotient rule right away because you see this huge division bar. That's usually the dead giveaway. So you would call this one f, and this function is g. So first I write, if I'm taking the derivative, so I'll write y prime to indicate I'm taking the derivative. You write low first, which is g, low. And then d high is the derivative of the top, which is 2x, minus then high, which is x squared minus 1, d low, which is 2x again, and then all over low squared, which is x squared plus 1 all squared like that. So again, just like before when I wrote the first line, that's technically the derivative. However, when you're doing application problems, like figuring out maxes and mins and stuff like that that we're going to do later, you typically set this equal to 0, and you want to transform it into something that's easy to work with. So I encourage you to just practice doing that now as much as you can, so you're basically ready for it when the time comes. So I'm going to go ahead and distribute first. So this is going to be 2x times x squared is 2x cubed plus 2x. Here I have this minus sign, so I'm going to switch the sign here. It's going to be minus 2x times x squared, which is minus 2x cubed. And then here I have a minus and another minus, so that's going to make plus 2x. And then this denominator is not really going anywhere, and it doesn't help us to FOIL it out, so I'm not going to. These cancel, which is very nice. And then this is equal to 4x over x squared plus 1 squared. So if you did ask yourself the question, where is that equal to 0, you really only have to make the numerator equal to 0. So you can see how this is a lot nicer to look at for application problems than something that's messy like that. So this is the derivative. Let's do another one. It's good to practice. So here is another one. F of x is the square root of x minus 1 all over e to the x. In the other video, what I was doing, and what I'll do now, is anytime I have a root function, I just rewrite f of x and give it an actual numerical power. For some reason in my brain, that helps me do the problem easier than just staring at a square root like that. OK, I'm going to do the quotient rule. So I'm going to straight up just do it right away. It's going to be low d high. So if you call this one f and this one g, it's going to be low, which is e to the x. The derivative of the numerator is going to be 1/2 x to the negative 1/2. Derivative of a constant is just 0, minus high, which is x to the 1/2 minus 1, d low. We talked about the derivative of e to the x is just e to the x in the last video. This is all over low squared. So one thing I do notice with this, to be able to clean it up, is we could say f prime of x is, and they both have an e to the x in common, this term and this term. So I could bring e to the x out. What's left is this 1/2 x to the negative 1/2. And then I have minus x to the 1/2 minus 1. So that's what's left in this term here. And this is over e to the x squared. And one of these and one of these is going to cancel out. So I lose this one, and I get e to the x here. So that's one way you could start cleaning this up a little bit. And I guess you could distribute a negative. But this is our derivative for this problem. Here we have an example that says, if f of x is a differentiable function, find the expression for the derivative, and g is a function where it's f of x over x squared. So this is a scenario where the function is given in terms of some symbol or another function name and an actual equation x squared. You should be able to take the derivative of both explicit equations, but also expressions that involve just a symbol name, like f of x. Regardless of what they give you, what rule would you use here? I have some function divided by another function. So you should be thinking the quotient rule for this. And we're going to do the quotient rule just like normal. So the derivative of g of x is, first I rewrite the bottom function, so low. Then I take the derivative of the numerator, so low d high. So what is the derivative of f? Well, the symbol for that is just f prime of x. And then minus sign, because I'm doing the quotient rule. So this was low d high minus, I'll introduce a giant bracket here just to make sure that I don't lose this negative sign here. Then I switch the order here. So this is, I'll rewrite the numerator, so high, and then d low. What is the derivative of the bottom function? That's 2x. This is all over low squared. So if I square a square, this is going to be x to the 4th power now. There's not too much you could do with this. But I do notice that every single one of these terms, this, and this, have an x in common. So you could divide out one of them from all spots, and you get x f prime of x minus, this x is gone, so I get minus 2f of x all over, and I've divided out one of these, so this is x cubed. OK, so that was taking the derivative of a function that was in terms of another function name. So in a moment, I'll practice another example with you, so stay tuned. Welcome back. So this is the second part to that last example I just did. So the same directions as earlier. F is given as a differentiable function. I'm going to find the derivative of g, which is 1 plus x times f of x, whatever that may be, over the square root of x. So this is going to involve both the quotient rule, because I have a quotient overall, and also it could involve the product rule, because x times f of x is a product of functions. So it's very possible, and it's going to be happening a lot, where you have many rules are involved in one derivative problem. Okay, I'm going to do this two ways. The first way is I'm going to rewrite this square root as being to the 1/2 power, like that. And then from here, what I'm going to do is I'm going to make things a little nicer for myself. So remember, you can always take the original, simplify or transform it first, and then take a derivative. So because there's a single term in the denominator, let's divide it to each piece here. So 1 over x to the 1/2 is actually x to the negative 1/2 plus x to the first power divided by x to the 1/2 power is x to the 1/2 power. So this over this will leave me with this. You just subtract the powers to do that. I would argue that this looks a little nicer to take the derivative of than this starting thing. So now let's go ahead and do it. So g prime of x. We need the power rule for this. It's a single function here. So bring the power down. I get negative 1/2 x. Subtract 1 from the power, and I get negative 3/2. That takes care of this piece. So I've taken the derivative of this. Now I go to the next piece. This requires the product rule. So what I'm going to do is give myself a bracket, because I know that the derivative of this is going to go in here, and I'm going to need some space. Derivative of the first one is going to be 1/2 x to the negative 1/2. That's the derivative of this. Leave f alone, plus, and I'm going to go ahead and switch the order now that I did this in. So now I'm going to leave this one alone, and I'll take the derivative of the second one, and that's just f prime of x. That's what the derivative is. Now I'm glancing at these, and I see that none of them really are like terms. I'm not going to be able to add them together. They all have a different power of x. And for a like term, they need to be the same power of x. So because this is just addition, please allow me to just do this. I'm going to erase these. And that's my final answer. So doing it this way, where I've simplified first and then just did one product rule, completely eliminated the need to do a quotient rule here. Let's suppose you didn't think to do that. Would you get the same answer? So let's go ahead and start with this one. So the derivative of this, using the quotient rule, first thing I would do is write the bottom one. So this is low. Derivative of the numerator would be derivative of 1 is 0. Derivative of this product, derivative of x is 1. Leave f of x alone. Plus, leave x alone, derivative of f. So that was low d high. And then I'm going to do minus high, which is the numerator, d low. The derivative of the bottom one is 1/2 x to the negative 1/2. This is all over low squared. If I square the square root here, this is x. So this is the derivative of g if I didn't do this simplification in the beginning. This looks kind of bad, right? But let's keep simplifying. Let's see if we can make this look a little better. I'm eyeballing this. I see we have an x factor in common. The lowest power of it that I see in common is negative 1/2. So I'm going to factor that out. 1/2 minus a minus 1/2 is x. Then I have f of x plus x f prime of x here, minus, I had this 1/2 here, 1 plus x f of x. And this x to the negative 1/2 was factored out here. This is all over x. So now if I take this x to the negative 1/2 and I move this to the denominator, where there's 1 here, this is going to mean that x to the 3/2 is sitting in the denominator. If I move this down here, let's go ahead and distribute this. I'm going to get x f of x plus, here I get x squared f prime of x, minus, this will be minus 1/2, and this is going to be minus 1/2 x f of x. So I just took care of this last distribution here. Does anything go together? You're probably thinking I'm nuts because here's the answer sitting pretty right here, and I'm doing all this work just to get this answer. You probably think I'm nuts. You're right. But stay with me. So this and this, they're like terms. They're both xfx. This is one of them. This is minus 1/2. So this is going to be 1/2 xfx plus the other two terms are not like terms. So I'm just going to rewrite this one and rewrite the negative 1/2. This is still over x to the 3/2. Take this x and divide it into all of these. And what we get is x. If I have 1x, or x to the first and x to the negative 3, this is going to be x to the negative 1/2. X squared divided by x to the 3/2 is x to the 1/2. And then a constant 1/2 divided by this power is going to be brought up as a negative power. And now I very nervously look at what I had for my answer before. I have negative 1/2 x to the negative 3/2. I have x to the 1/2 f prime of x. And I have 1/2 x to the negative 1/2. OK, so every single thing checks out. So this is exactly what I had before. Let this be a lesson to you. Really think about what you're doing before you just fly into the derivative. Because sure, you could be a little robot and you can be really good at finding the derivative. But if you have a nasty expression and you can't find it in the answer choices, like for a multiple choice, or if you have no way of manipulating this to find the zeros, what good is that going to do you? Save yourself some work. Think before you go into it, what might be a better way to write the derivative? So you have this option, or if you split it up, it's really fast. This one takes kind of forever to uncover what the final answer would be. So yeah, just things to think about. Please make sure you go do your Chronos homework and your lecture quizzes. And as always, send me questions if anything is tripping you up, basically, in the material, OK? Until next time, I will see you in Lecture 13. OK, bye.